Okay, so as a quick review, yesterday we talked about significant figures as a measurement of precision. And there were some issues with zeros. So real quickly on the rules for zeros, if it's in the middle, it always counts as a significant figure. If it's at the beginning, it never counts. And then if it's at the end, depending on whether you have a decimal point or not, whether it counts or not. And then I went through these examples here. Okay, so we talked about addition rules. And there you're looking at the answer to the addition or subtraction is going to be the smallest number of decimal places. As far as multiplication, division, and exponentiation, it's sort of the same, only you're looking at the total number of significant figures in the numbers. And then the answer is going to have the smaller of the two. So in this case here, this first example, this has 2 sig figs, this has 3 sig figs. Your answer is going to have 2 sig figs. So you go to the third place, and that determines what the second place will be. If it's 0 to 4, you drop it. If it's 5 to 9, you increase it by 1. Okay, so what we didn't talk about yesterday was exact quantities. For example, exact quantity will be something like 12 equals 1 dozen. It's not 11.9, it's not 12.1, it's exactly 12 by definition. So the sig figs on this guy is infinite. So in other words, the exact quantities are not going to come into the calculation because they're infinite. So everything is smaller than infinite. Also, when you're counting, for example, I hit the desk 3 times, not 2.9, not 3.1, exactly 3 times. So that count also has infinite sig figs. Okay, now this material is covered in the online book. And here's a link to it here. But there's an active link in the syllabus. And you can download sections if you want. You can download the whole thing if you want. I don't know how many pages it is, but it's quite long. So that, in fact, I downloaded it right here. This is what it looks like. This is section 1.9. Talks about rounding and it gives some examples with answers. So basically, I'm going to be following this fairly closely. So you've got the videos of me going over this stuff, and you also have the online textbook. You also have free tutoring at the library. Okay, so there's another thing I didn't talk about yesterday. It's called order of operations. Order of operations determines what gets done first. So it's abbreviated like this, PEMDAS. And it stands for parentheses, exponents, multiplication, division. Those are equivalent, because division is the inverse operation of multiplication, and then addition, subtraction, and subtraction is the inverse operation of addition. So we go from left to right as far as being what should be done first. Now let's take an example. 1.1 times 1.52 plus 300, or excuse me, plus 3.00. Okay, so we go in the order of PEMDAS. This is multiplication, so it falls right here. We have no parentheses. Go ahead. Someone have a question? Okay, so these parentheses don't define an operation. It's just separating this number from that number. However, this is a multiplication problem right here. So that falls right here. So that means this is an addition problem here. Multiplications be done before addition. So we have to do the multiplication part first. So that's right here. 1.1 times 1.52, that equals, according to my calculator, 1.672. Now, multiplication problems require you to look at the sig figs of the answer. This has 2 sig figs, 3 sig figs, so your answer is going to have 2 sig figs. So we round the 1.672 to 2 sig figs. So we go to the third place, and that's 5 or greater, so that kicks the 6 up to a 7. So the answer is 1.7. Now that's just the multiplication part. Now we have to add that to the 3.00. Adding those together is 4.70. Now, for when you add or subtract, you only look at the decimal places. This has 1 decimal place, this has 2, so our answer is going to have 1 decimal place. So our answer is going to be, you go to the third place, or the second place, decimal place, and that determines what the first decimal place will be. 0 to 4, we drop it, so the answer is 4.7. Okay, so order of operations. It's crucial that you apply this. Now, let's do another example. Here we have a division problem. Now, fractions and division are one and the same in all quantitative courses. Fractions is the same thing as division. You won't see this written like this. Most of the time, you'll see it written like that. Okay, so we have division going on, and we have subtraction. Division takes priority over subtraction, so we need to do this, do the division first. Let me do one other thing here. I need more room. Okay, so we can do the division first. So we're going to divide 2.47 by 1.111. And my calculator gives me this really long answer. So this is 4 sig figs, 3 sig figs. So our answer to this is going to have 3 sig figs. This is what my calculator tells me, 2.223222322. Now that's not 3 sig figs. So we need to go to the fourth place. That 3 is 0 to 4, so we drop all of this. So our answer is going to be 2.22. This is 3 sig figs. Now, it's going to be 2.2. We're going to continue this problem now, minus the 3.1. So we have 2 decimal places, 1 decimal place. So our answer is going to have 1 decimal place. Okay, so we're going to go 2.22 minus 3.1. That's going to be minus 'Okay. So our answer is going to be 1 decimal place because of this guy here. So we're going to take the second decimal place. That's going to kick the first 8 up to a 9. So that's our answer. Minus 0.9. Notice I'm putting zeros here. You're going to find that standard in science classes to always put a 0 in front of the decimal if the number is less than 1. If you're going into clinical science, which a lot of you are, it's extremely important to put the 0 on the front, whether it's handwritten or typed. And the reason for that is there's been some unprecedented children's deaths because of prescriptions were off because the decimal point was misinterpreted. Hence the convention of always adding a 0 out front. So if a 0 is out front, you know there's a decimal point there, no matter how small. Okay, so yeah.
Can you just re-explain this last line? So the decimal point, I think I'm just missing something there, where you wrote the decimal point under the 2.22 and the 3.1. Can you kind of explain that a little bit? Like, again, maybe I'm missing something there. And how you
Yeah, so whenever we add or subtract, we go by decimal places. When we multiply and divide, we go by the significant figures of the whole number. So we're looking at decimal places
Okay.
here. 1 versus 2. It's always the smaller one. So that means our answer is going to have 1 decimal place. Our calculator gave us 0.88. So 2 decimal places. So we have to convert it to 1 decimal place.
Okay.
Better?
Yes, better. I think got mixed up because on the other one we were doing the division and multiplication, and like you said, it's a different
Yeah, it's
rule for that
slightly,
one.
yeah, slightly different. And then we're going to be mostly doing multiplication division, like I was saying yesterday. This is just an example of a mixed problem here. We have combination of division and subtraction.
So basically, like you said, follow the sig fig for the multiplication division, and then decimal point for the addition or subtraction.
Exactly. Exactly. Okay, good question.
Thank you.
All right. Now let's look at this guy here. Okay, so we've got a combined multiplication and division here. Now this problem here is a good illustration of the typical problems we're going to see in this class, where we have mixed multiplication and division. Now I'm going to show you a way, I'm going to show you 2 ways to do this problem. One way is prone to errors, but a lot of students frequently do it this way. Okay. Now we have multiplication on the top of the fraction bar and is divided by the 343. So a lot of students will do the top operation first and write down an answer. So they're going to go 271 times 11.1 equals, I'm going to write this number down. And now do the division problem. And then they'll get their answer. Okay, so we're looking at 3 sig figs all the way around. So we've got to go to the 4th place here, which means this is 8.77 as an answer. Okay, so that's one way to do it, where you have you're writing down an intermediate product. The problem by doing it this way, you're setting yourself up for possible transcription errors. The better way to do it is let the calculator keep that number internally. So the way I'm going to do it, I'm going to go 2.71 times 11.1. Now, any number on the bottom, I'm just going to hit the divide key. Divide 343. Enter. And I get the same number. No intermediate step. Now, this doesn't matter how many numbers are on the top, how many numbers are on the bottom. Let's do another example. Let's do 171 times 3.34 divided by 2.07 divided by 9.08. Okay, so here we've got numbers on the top, numbers on the bottom. So whenever we have numbers on the bottom, we're hitting the divide key. If we have two numbers on the bottom, we're going to hit the divide key for each number. So I'm going to go. In fact, this problem, most students will do two intermediate steps. They'll do this multiplication, then they'll do this multiplication on the bottom, and then they'll divide those two. Again, it's prone to errors when you keep having to write things down. Calculator, 1.71 times 334. Now, a number on the bottom, I'm going to hit the divide key, 207. Now I'm going to hit the divide key again for the 908. Enter. Okay, I've got 3 sig figs, 4 sig figs, 3 sig figs, 3 sig figs. So our answer is going to have 3 sig figs. Okay, so I'm looking at 304. So a good way to remember this technique is everything on the top, you hit the multiply key. Everything on the bottom, you hit the divide key. No intermediate steps. The calculator does all the intermediate steps for you under the covers. Okay, does that make sense?
Yes.
Yes.
Yes, it makes sense. I tried it on my calculator. It seemed to work that way as well.
Cool. Okay, now yesterday I mentioned if you're in the market for a calculator, make sure it's got this EE key on it. Let me show you how that works. Whenever we're doing scientific notation, that's when we're going to use the EE key. I don't know what the EE stands for. No, one of the E's stands for exponent. Okay, so what the EE key does is it substitutes for the times 10. And the 4 is the exponent that follows. So to write this in your calculator using your EE key, you're going to go 1.15, hit the EE key, 4. And what you'll see is a little e, 4 on your calculator. Most of the time. It depends on your brand of calculator. Sometimes they'll actually put the 10 in. But most of the time they'll just have a little tiny e. So that's what you'll see on your screen, on your calculator. So let's do this problem here. So we've got 4 numbers now, all of them in scientific notation. How would we do that on your calculator? So we've got numbers on the top, we're multiplying, numbers on the bottom, we're dividing. Now there's 2 ways to do this. If you don't want to use your EE key, you're going to have to use parentheses. No exceptions on the bottom only. On the top, it's optional, but on the bottom, it's required. So to do this problem, we're going to go 2O EE 3 times key 314 EE. Change sign 2. Now, if you look on your calculator, there are two minuses. They're not the same. One is subtraction, the other is a negative number. Most of the time, it's on the bottom, where the subtraction is on the right side. So, and then I'm going to hit the divide key, 1.1 or 1.2 EE, 5. Divide key again, because it's on the bottom, 17.34 EE, 4. Enter. So we're going 2 EE 3 times 314 EE, change sign 2 divided by 1.2 EE 5, divide again, 17.34 EE 4. And it helps to turn your calculator on. Uh, okay, so my answer is, and that's 2 sig figs, 2 sig figs, 3 sig figs, 4. So my answer is going to be in 2 sig figs, which is going to be 3.0 times 10 to the minus 9. Okay, I'd like for all of you to try this and see if you get this answer. That is, if you have your calculator handy. If you don't have your calculator,
I recall yesterday you saying depending on what calculator you have, like when you go to use that button, there might be something that you have to do beforehand. Or am I mixing?
on what now?
It's okay. I think I'm mixing myself up with. Okay, I remember you saying something about depending on your calculator, it will depend if you either have the button or how you have to use it. A certain way of how, like,
Yes,
shift it.
if your calculator has the EE button in a shift location, then you have to press the shift key and then EE.
Okay, that's what it was. Okay.
That's what's nice about this TI 36. You don't have to shift to get to the E. Where my TI 84, you've got to shift to get to EE.
Oh, that's what I have too. That's why. Okay, that's what I have. Okay. Thank you.
You have an 84?
Yes.
Yeah, okay, that's a wonderful calculator, except for EE key, you've got to shift. That's the only thing.
Okay. Thank you.
Now, there's a problem with that calculator with certain teachers. And I'm talking about a math class. Depends on, see, that calculator can do calculus and differentiation and all kinds of stuff. So some teachers won't allow you to use a graphing calculator. Now, I don't mind if you use a graphing calculator in my class because you can clear the memory and it's just like any other calculator. But I'm just saying, you might get that pushback from certain teachers.
All right. Good to know. Thank you.
Did anyone not get 30 times 10 to the minus 9? That are using their calculators? Okay, if you don't have an EE on your calculator, This is the way you're going to do it. You're going to go, and there are lots of extra steps if you don't have EE. Okay, you're going to go 2, oops, 2.0 EE. I'm sorry. 2.0 times 10 caret 3. Oops, and those are times there. 314 times 10 caret 2 divided by parentheses 1.2 times 10 caret 5 divided by 17.3 times 10 caret 4. Enter. Now look at all the steps I had to add because I'm not using EE. Every time I hit EE, this part was minimized. That's 3 keystrokes right there, not counting the parentheses. So where this one, look how many less steps I took up here. So that's why I highly recommend getting a calculator with EE in it. Okay. Now today's lecture is not going to go as long as yesterday's because they ended up being late to lab. So we're going to end this a little after 5. Give myself plenty of time to get to work. It was raining on the way to the lab yesterday as well. So it was like delay after delay after delay. So anyway, okay. You guys have any questions about order of operations and this is explained in this here as well. Also, there's the tutoring center. Free tutoring center, I might add. It's not really free, you pay for it in your tuition, but anyway, there's no upfront cost. Okay, well, let's go ahead and go on then. Now, yesterday I introduced scientific notation. And scientific notation is defined as standard scientific notation, I should say, is defined as the first part is a number from 1 to 9 times base 10 with an exponent of either negative or positive of some number, some integer. It doesn't have to be an integer, but usually it is an integer in the lower division classes like ours. Okay, what if it's not in standard notation?
There's usually a bunch of zeros, either leading or on the following end.
You can have zeros. For example, we can have, we're going to change this to, you can have zeros like that, but then see the number is still from 1 to 9. Doesn't matter how many decimal places you have here, as long as it's a number from 1 to 9. This is non-standard because this number is not from 1 to 9. It's above 9. Okay, so how do you convert this non-standard number, 12 times 10 cubed, to the standard format? Well, the first thing, it's a 2-step problem. And there are 2 ways to do it. I'm going to show you the way that most students get it. what you do is you can just take it and convert it to a non-scientific notation number. So to convert this, you've got 12 with 3 zeros after it, 12,000. Now, this is where the decimal point lies. So to convert this to a number from 1 to 9, 1.200, we're going to move this decimal over 1, 2, 3, 4. And that's where this 4 comes in. So these two numbers, let me make the zeros in here. These two numbers are equivalent now, but one is in standard notation, the other is in non-standard notation. And again, like I said yesterday, some teachers require you to put all the numbers in standard notation, standard, and I don't require that because the purpose of this is to make awkward numbers non-awkward. For example, this number here, very, very awkward, so we converted it to scientific notation. So if this number is not awkward for you, which would be a pain to put in your calculator, putting 6.02 times 10 to the 23rd in your calculator is pretty easy. You're going to go 6.02 EE 23. Done. So to convert from non-standard to standard format, you write the number as non-standard notation and then convert it over to standard notation. Okay, does that make sense?
It does. I'm confused on why the 12 times 10 to the third is not standard format.
Okay, good question. By definition, this number here has to be from 1 to 9. And 12 is not a number from 1 to 9.
Copy that.
Yeah, I did. Thanks for clarifying that. I'm still a little stuck on.
I'm sorry, can you repeat that one more time?
Okay, so standard scientific notation requires the first number to be a number from 1 to 9.
And
If it's not,
non-standard is everything above that, correct?
or below it,
Oh, okay.
because we have see, that's non-standard as well, because this is less than 1. So to convert this, we would write it as we'd have 1 in 4 places to the right. 1, 2, 3, 4. So this would end up being 1, 2, 3, 4. So it's going to be 1 times 10 to the square. Excuse me, not squared. Um, 1, 2, 3, 4, yeah. So that number's ending up being 100, so that's squared, yeah. So you've got to take up these 2 places to get it to 1. That means those are subtracted from before. Most of the time, you're going to get numbers like this that are non-standard. Numbers greater than 9. And then you just write it out like this. So that's the main thing on scientific notation, is making sure your format is standardized.
In the book, is there practice where we can kind of practice on this?
Yes, but not very many of them. I would recommend, if you want practice,
Just to make sure I understand the concept.
go to Canvas. Where is Canvas on here? go to Files,
Mhm.
and you want Unit 1, and these are all the worksheets that I have for practice.
Okay.
And they come with answers.
Yes, I did open that. Okay, I didn't know it was specifically for. Okay, got it. Thank you.
Yeah, so for example, so you've got lots of practice and the answers.
Okay.
Okay, you guys are asking some really good questions. Okay, so what we're going to do now is we are going to go to the next subunit. So we need to go to we are going to do something called unit analysis, or let's see. Or dimensional analysis when you spell it right. Okay, so now we're going to get into problem solving. And the technique that all, without exception, all engineering quantitative science programs use is unit analysis, dimensional analysis. There's another one too, call it. Depending on your textbook, depending on your instructor, they'll use these interchangeably. Basically, it comes down to this. I have a system I developed a long time ago. In giving students a strategy to work word problems. Most students, they go, word problem? Oh my God. They space out big time with word problems. And I'm going to give you a strategy on how to do them. This is what it is. Every problem we're going to do in this class is going to follow this strategy. Step number 1. If there is a chemical reaction, balance it. Now, in the beginning, we're not going to have any chemical reactions, but very soon we are. So the first step is always balance the chemical reaction. Number 2, what is given? Number 3, what is to be calculated? And then 4 is the setup. Every single problem we're going to be doing from now till the end of July follows these 4 steps. Now, step number 2 is, this is assuming we're given one quantity. Sometimes you're given 2 quantities as the given, and then this gets a little more complicated, but it's basically the same thing. Okay, so no chemical reaction, skip number 1. Number 2, what's given? And then the other thing is think left. and think right. And then what we're going to be doing is calculating the setup is basically you start with something on the left, which is a given, and through conversion factors, we're going to be getting to what's on the right to be calculated. Okay, now this will make more sense. I'm going to give you zillions of examples. Okay, so let's use a really hard example that most of you probably can do in your head. Okay. You have 15 apples. How many dozen are there?
1.
Oh, what? Okay, so do we have a chemical reaction?
No.
So skip number 1. What's given?
15 apples.
15 apples, exactly right. Okay, what are we trying to calculate?
How many dozens?
Yeah, dozen, right? How many dozen? So now we do the setup from left to right. Okay, so you need to know some conversion factors. So how many dozen, how many apples are in a dozen?
Well,
12.
1.
12.
12. Yeah, it's 12.
Right? Everyone agree to that. Okay. Now, every time we get a conversion like this, we are going to convert it to 2 fractions. One fraction is 1 dozen over 12 apples, and 12 apples over 1 dozen. Those are equivalent. The reason why they're equivalent is these have to be equal, because 5 over 5 is equal to 1. And then if we switch these, let's call that 5 prime. 5 prime over 5 is equal to 1. So that's why they're equal. All right, so now we're going to apply these conversion factors to 15 apples. Now, as an aside, over here, now this goes back to elementary algebra. If I multiply A times C over A, what is my answer? What do you get? Right. C. The reason why you get C is the A's cancel. So if you have anything over fraction bar and under, they cancel. So our answer is C. Now we're going to apply this. This is where the name unit cancellation comes in. We need to convert apples to dozens. So we have 2 conversion factors to use. Now you don't have to guess which one to use, because we're going to apply the unit cancellation here. So So we have 15, think of it as 15 on top of the fraction bar. So we need, now remember, this is the given now. So how can we cancel the 15? So we've got 1 dozen up here, 12 down here, and this is 12 apples. Now we're using this one because that means the apples are going to cancel. And what does it leave us with? Dozen. That's the setup. So if we use the other one, where we had dozen on the bottom, 12 on the top, apples wouldn't cancel. So given always has to cancel. No exceptions. Okay, so everyone see why apples cancel? It's just like with the C over A. A's cancel. Now this is a one-step problem. So if this problem was worth 10 points, this setup is worth 9 points. Your answer is worth 1 point. Because the setup is where the chemistry is, not how to use your calculator. Okay, so the answer is going to be 15 divided by 12. $1.25 dozen. Okay, so is that the correct answer? What's wrong with that answer?
You said that it can't be like, it has to be a, what is it? What was it earlier? An infinite? Like, it can't be
Scientific
0.25.
notation.
Okay, this is by definition, 12 to a dozen. So that has infinite sig figs.
Mhm.
Figs does 15 have?
2.
2. So how many sig figs do our answer have?
2.
2. This is 3.
3 6 figs. 1.25.
1.25 has 3 sig figs. So we go to the third place, that kicks that 2 up to a 3. So our answer is 1.3 dozen.
Huh.
2 sig figs. So to get the answer right, you have to have units, sig figs, and the correct number to get that 1 point. Now that's where I'm going to end this because it's 4:59, and we're going to do a whole bunch of examples tomorrow. So the main thing today is, did you mostly follow this?
Yes, I did have one question.
Sure.
I mean, I don't know if you're getting to it tomorrow, but how does this relate to the chemistry? Is it like if they're in the same unit of measurement, you would just take away the chemicals and do the problem by itself?
No, you leave
Or-
the chemicals in.
I'm just confused on how this relates. Maybe you're going to get to it a little later.
Yeah, for example, I could say, reword this problem saying, if you have 1.5 grams of water, how many molecules of water do you have?
Okay, that makes sense.
It's unit cancellation. And I'm going to show you how to do that either tomorrow or Thursday. Because I haven't introduced any chemistry yet. All we're doing is mathy stuff. So that when we get to the chemistry part, you'll understand it, how to set things up. Setup is the name of the game in this class. It's, like I was saying, 90% of the points come from the setup, not from your answer. So you could do this whole class without a calculator, just doing setups. Or you could do it by the long way. Back, oh, this was a long time ago. This was probably 19, 20 years ago. I had a student that was actually older than me. He didn't believe in calculators. He did everything by hand. He did long division by hand. He did square roots by hand. He did multiple, all long ways. And he got an A in the class too. He sat in the back. He never asked one question, and he just blew the test off. I made a copy of his test, and I don't know where it is. It was a cool guy. But other than that approach, you don't, to get 90% on all your tests, you don't need a calculator. That'll help if you do have a calculator. But theoretically, you just set it up and then go on to the next problem. Okay, so I'm going to end here, and we're going to investigate this because this is a big deal. This subunit on unit analysis. It's a big deal. Okay, let's see. Any questions about?
What do we need to have with us for the lab today?
I'm sorry, say again?
What do we need to have with us for the lab today?
Shoes. Lab appropriate shoes. And I'll give you everything else. If you want to bring your Dry Lab 1 also to get started on it while I'm there, I'll be more than happy to work with you on it. But the bottom line is I need to take attendance. I need for you to, I need to give you the paperwork that you need to submit. And then you need to find a lab partner and choose a drawer for your lab stuff. Last night's class got out around 8 o'clock. I think they were socializing at the end. That's why it went so long. Now, including waitlisted people on this too. So I need to have you sign off that your attendance was there. Because you cannot get in the class if you're waitlisted and don't attend. No exceptions, unless you communicate with me for accommodations or whatever. Same with enrolled people. If you miss this week's attendance, you will be dropped. The school's got a big policy on that. No shows are dropped, period, unless you communicated with the
Here.
Huh? No, I thought someone had a question. Okay, so let's see. Yes, this is stoichiometry, by the way. Very good. You can do a partner now, or you can do it in lab. Yeah, Avery. Exactly, Mari. Waitlisted students just have to show up on the day that they signed up for, either Monday, Wednesday, or Tuesday, Thursday. And even then, it doesn't really matter. The main thing is because my sign up or my attendance sheet isn't. I just have all the enrolled people, regardless of Monday, Wednesday, Tuesday, Thursday, and the waitlisted people are the same way. So my list doesn't differentiate between the two. So really, this first week, you just show up one of the days. If it's a long drive or something like that. I want to try to accommodate this driving stuff. For cost of gas looks like it's going to be going way up from what it is now, and it's anyway very frustrating for me. Okay, so I will see Tuesday, Thursday, folks, in a little while. And take care, you guys. We'll get into this problem solving big time tomorrow. Big time. You guys are funny. All right, now let's see here. I'm going to stop the recording.